All right, let's talk about a tool that has completely changed the game for how we build and manage pretty much everything in the cloud, Terraform. If you've ever wondered how these massive companies can roll out new features across thousands of servers, like all at once and without breaking everything, well, a huge part of that magic is what we're about to get into.
So picture this. You're an engineer and you need to set up a new server. Easy enough, right? You log into your cloud provider, click a few buttons, maybe fill out a form or two, and you're done. But what happens when you need 10 servers or 100? Or what if you need 1,000 servers and they all have to be exactly identical? Trying to do that by hand? It's not just hard, it's a nightmare. It's basically a recipe for total disaster. And that is the problem we need to solve.
The old way of doing things, manually clicking and configuring servers, is just painfully slow. And it's so easy for a human to make a mistake. One wrong click, one typo in a configuration, and you could bring down an entire system. And, maybe most importantly, in today's world where speed is everything, it just doesn't scale. This chaos is really what pushed the whole industry to find a better way.
And that better way, that solution, has a name: infrastructure as code. I mean, the name pretty much says it all, right? Instead of clicking around in some web browser, we're going to start treating our infrastructure, our servers, our networks, our databases, all of it, the same way we treat our software, as code.
So what does that actually mean in practice? It means you define everything, your servers, your firewalls, your load balancers, in simple text files. These files become the one single source of truth for your entire setup. And because it's code, you can do all the cool stuff you do with software code. You can put it in version control, you can have your teammates review it, and you can automate the whole process. This is a massive shift, and it's really the bedrock of how modern cloud companies operate.
Now, of course, if you're going to do infrastructure as code, you need a tool for the job. And one of the biggest, most popular tools out there is Terraform. So let's zoom in and get to know it a little bit.
Terraform didn't just pop up out of nowhere. It was created way back in 2014 by a guy named Mitchell Hashimoto to solve this exact scaling problem. It started pretty small, just supporting AWS and DigitalOcean, but people saw the potential right away. It's written in the Go programming language, which makes it super fast and efficient, and since then, it's just exploded. Today, it's an absolute powerhouse for managing these huge, complex systems that span multiple clouds.
So how do you actually write this code? Well, Terraform has its own special language called HCL, which stands for HashiCorp Configuration Language. You can kind of think of it like JSON's more friendly cousin. It's all about this simple key equals value format. You literally just write things like instance type equals large or region equals US East -1. It makes describing the infrastructure you want to build incredibly easy for humans to read and write.
Okay, this next part is really important. Not all of these infrastructure as code tools think the same way. There are really two main philosophies, two different approaches, and understanding this difference is key. We call them the declarative approach and the imperative approach.
Let's use an analogy to make this super clear. Think of the imperative approach like a detailed recipe. It gives you very specific, ordered steps. First, preheat the oven. Second, mix the flour and sugar. Third, add the eggs. The order of those steps is absolutely critical. The declarative approach, on the other hand, is like just showing a picture of the final dish. You just say, I want this chocolate cake, and the tool, the chef, figures out all the steps to get you there.
So here's what that imperative style looks like in the tech world. You have to tell it every single step in exactly the right order. You have to say, first, create the big private network, the VPC. Then, after that's done, create a subnet inside of it. Then, add an internet gateway. You see, if you mess up that order, the whole thing fails. The burden of knowing how to build it is all on you.
Now, with the declarative approach, it's like night and day. You just make a list of what you want. You say, hey, I need a VPC, a subnet, and a gateway. You don't tell it the order. The tool is smart enough to look at your list and understand the dependencies. It knows you can't build a subnet until the VPC exists, so it automatically figures out the correct order to build everything for you. It's a huge difference.
So where does Terraform land in all this? Well, Terraform is firmly in the declarative camp. You tell it what you want. It's joined by other tools like AWS CloudFormation and Azure's ARM templates. That other approach, the imperative how-to recipe, that's most famously used by a tool called Ansible. And mentioning Ansible brings us to what is probably the #1 point of confusion for people starting out. People often ask, so is Terraform just like Ansible?
And the answer is a big, definite no. And the difference is super important. They're designed for two completely different jobs. One is for provisioning, and the other is for configuration.
This quote from our source material just nails it perfectly. Let's break it down. Terraform's job is to create the things themselves, to provision the servers, the networks, the core building blocks. Ansible's job is to come in after those things exist and then install and manage the software on them.
So really, they're not competitors at all. They're partners. A super common workflow is to use Terraform to stand up the basic infrastructure, like a new virtual server. Then, as soon as that server is up and running, Terraform can actually hand off the job to Ansible. Ansible then logs into that brand new machine and takes over, installing and configuring all the software it needs, like a web server or a database. They work together.
To really make this whole idea stick, let's use one last analogy that I think clears everything up perfectly. We'll call it the laptop analogy.
This is really the key insight. It's all about what gets built versus what gets installed on top of what was built.
Okay, think of Terraform as the factory that builds your brand new laptop. It assembles all the physical hardware, the motherboard, the CPU, the memory, the hard drive. It even installs the basic operating system. It's creating the foundational infrastructure, the machine itself. Then, once you've got your new laptop, you use Ansible. Ansible is what installs all your applications. It's what puts Chrome and Spotify and all your work software onto the machine. It does the software configuration that runs on top of the infrastructure that Terraform just built. It's what makes the laptop actually useful.
So, if we want to boil it all down to one simple sentence, it's this. Terraform builds the house, Ansible furnishes it. One creates the structure, and the other puts all the useful stuff inside. They're two different, but equally important sides of the automation coin.
And that really brings us to our final thought for today. This whole shift to managing everything as code, it's not just some small technical change. It's a fundamental revolution in how IT works. So as everything, from our servers to our most complex network setups, becomes defined in a simple text file, what does that mean for the future of IT roles? What skills will be most valuable in this new world? It's a big question and definitely something worth thinking about. Thanks for tuning in.